Hey guys, how you doing today? Just wanted to talk about some proper air conditioning setup, specifically about airflow, because as we all know, we should really focus on airflow before charging when we're looking at air conditioning systems. So let's begin on that. So really, if your airflow is not correct, nothing else is going to be right. So we really need to make sure everything's good with that. So when we're talking airflow, we're not just talking about the indoor side, but also the outdoor side. So on the indoor side, typically 400 CFM per ton is what we're looking for. If we're in a humid climate like Florida, we might want to do 350 CFM per ton, or if we're in Arizona where it's really dry, we might want to do 450 CFM per ton. Where we live in Ohio, usually 400 CFM is going to do it. So before setting airflow, what do we need to do? We need to make sure everything is clean, functioning properly. Fan wheels are in good shape, motors are good to go. So you can see here, we got a little picture of a dirty coil. Let's just go ahead and get that dirt out of there, make it clean. So, outdoor coils are pretty easy. I mean, you can see them, you can get an idea of if they're dirty or not, clean them pretty easily. Indoor coils, on the other hand, those can sometimes be a challenge. If you have a coil that's behind sheet metal, I mean, you're going to have to start taking apart sheet metal. I don't know about you guys, but I'm not always the best at putting that stuff back together afterwards. So what can we do in this case? I mean, we can take cameras and look up inside. We could pull the limit, put a camera in, see if the coil's dirty. We also could use our buddy static pressure, to figure out what's going on with that coil to see if there's some sort of an excessive drop. So let's talk about static pressure for just a minute, because I love static pressure. Critical for proper system operation. Typically on residential, I mean, we're going to be looking for 0.5 as our total external static pressure. Can't always get there. We have restrictions on duct work where it's not practical for the customer to rip out duct work, but we want to get as close as possible. So we got 4 things we're going to look at. Typically the 4 main readings we want to look at are return static before filter, return static after filter, supply static before coil and after the coil. So if you're seeing issues with, before the filter, high return static, I mean, you can look further down the line and, kind of see where your restrictions are. Same thing on the supply, you could see if maybe something's closed off or something like that. So yeah, really those 4 main readings will tell you everything you need to know. So speaking specifically about your coil, if you take before the coil and after the coil, you're going to get your drop, and we're going to be able to use that to figure out if we're in the ballpark or where we need to be. So ideally, you would have the manufacturer's data on what the pressure drop should be across the coil. It's been pointed out that that's not always easy to get, which I agree with. So we'll talk about some numbers we could use to get an idea if we're in the ballpark or not. But just for example, we'll pretend like we're able to find this data sheet and kind of go through it easily. So again, we're going to take our readings before and after the coil. So before the coil can sometimes be a challenge because you might have a coil right on top of a furnace. What I've always done is I pulled the limit out and taken my reading there. Now, some people will say that you can't get an accurate reading there, which if you want to be technical is probably true. I mean, there is, some air that kind of builds up below the coil and you get some resistance there. But I would rather do that than start drilling into a furnace or drilling into a coil to get that reading, if I'm being honest. Unless it's, really in question whether or not my reading is correct there at the limit, I'm probably going to go with that number. Then, after right above the coil, you get your reading there. You take your higher number before the coil, subtract your lower number after the coil, and then you get your pressure drop there. So we're going to compare that to our chart here. So we're going to go ahead, and I highlighted a coil on this chart, and we observed a drop of 0.3 across it. Let's say our system is set up for 800 CFM airflow. So if we look at the chart under 800 CFM, it's going to show us a wet and dry reading on this chart. So if we're wet, we're going to be, about 0.25 on that. If we're dry, we're going to be about 0.16. So in this instance, if we're checking it while it's a dry coil, if we're reading 0.3 and we should be running at 0.16, then I would definitely be, taking a look and offering a coil cleaning on that. If we're at 0.25, I mean, we're kind of borderline there where there's, you know, at 0.3, probably some buildup, some little bit of blockage in there. We might want to talk to the customer about treating that. So most likely it's dirt. I mean, you could have where an install manual gets left in there for some reason. If the pan below it didn't get cut out enough, that could also cause an issue. So once you see that reading, I mean, that's when you got to commit to getting in there and getting involved into seeing what's actually going on. So let's say you don't have that information, you know, in those instances. I mean, if we think about system design, if we think about we're trying to achieve that 0.5 total external static, you know, after your filter, if before your blower, after your filter, if you're about 0.25, you know, you're probably going to expect before your coil to be, you know, 0.3, 0.4, if we're on a properly designed system. After the coil, you know, let's just round up to 0.1. So if you're seeing pressure drops of, say, like 0.4, 0.5, in that case, you know there's some sort of restriction, something going on there, dirt or something like that. So when you have those numbers, you can confidently say that, hey, we need to open this thing up, probably clean it, or find some kind of blockage. So let's talk about airflow next. So how can we set our airflow? How do we know that we have the right airflow? So we'll talk about if we have a PSC system or if we have a variable speed motor. So here we're setting up a PSC system. Luckily, we have a blower chart from the manufacturer. We're going to pick this furnace highlighted here, this DD80HS from Daikin, and we're going to go ahead and set it up for 2 tons of AC. So we're looking at about 800 CFM is what we're trying to achieve. It shows here a recommendation for 2 tons would be the medium low. And so we're going to check our static. You know, we are going to use 0.5 just for an example. And so if we take a look on medium low at 0.5 inches water column total static, we're running at about 900 CFM or little over 450 CFM per ton. So in that case, we might want to consider switching down to low speed, depending on your climate. And so if we switch to low speed, then we're at 723 CFM or about 360, you know, CFM per ton. So we'll get a little bit better dehumidification and, you know, probably benefit the customer doing that. So what if we don't have a blower chart? What can we do? A couple different routes you can take, some rules of thumb, some more scientific things you could do. So if we look at our model number, usually you can get the actual blower tonnage off the model number. So here we have a Daikin furnace example. So the 3 in that model number indicates a 3-ton blower. We'll use another furnace, a Luxair, as an example. The 12 in there indicates 1200 CFM or 3 tons. So usually in the model number, you can extrapolate some sort of a tonnage in there. So at normal static pressure, 0.5 inches water column, we'll say somewhere in that ballpark. If we have a 4-speed blower, we'll know that the high-speed tap is going to be 4 tons because it's, in this example, it's 4 tons because we're using a 4-ton blower. So then medium high, we can, you know, rule of thumb estimate it's going to be 3.5 tons, medium low 3 tons, and low will be 2.5 tons. So again, rules of thumb, it's not exact science, but something at least get you in the ballpark and kind of know where you're at. You know, whenever possible, please refer to a blower chart. That's really important. Other way you can do is we can actually use a little bit more technical method. We can, you know, use furnace temperature rise to determine what our CFM are on the system. So let's say we think that it's going to be, you know, medium low, that we want it to be for cooling. We can set that tap onto cooling. We can set medium low onto cooling, and then we can run our furnace and take our temperature rise. We've got to clock the meter to actually verify the input. Then we have a formula here. We're using BTUs times efficiency divided by temperature rise divided by 1.08, and that'll give us our CFM. So for this example, we clock the meter, we clock the input at 80,000 BTUs at 80% efficient, and we have a 51-degree temperature rise. So we'll do 80,000 times 80%, I think, is 64,000, divided by 51 divided by 1.08 would be 1162. So we know we have about, you know, 3 tons of airflow on this blower tap. So, you know, a little bit more scientific than just kind of guessing. So I definitely recommend this over doing like a rule of thumb method. So ECM variable speed motors, you know, you're going to have to refer to the manufacturer as far as setting dip switches. You know, equipment needs to be clean. It's critical. We need to have, you know, good filter, no restrictions, so that ECM motor doesn't ramp up to achieve our airflow, because it's going to get our airflow. It just might have to use, you know, 3 times the power to get there if we got a lot of restrictions. So again, refer to manufacturer's instructions. So I just, you know, highlighted some manufacturer's instructions here. You know, we selected our furnace. We looked at what our CFM is. So in this example, we're using 3.5 tons. We're going to select our closest airflow that we have, which would be tap C for high stage cooling is 1284. And then we can use our trim on this particular furnace. You know, some furnaces have a trim setting where you can adjust by percentage. So in this example, we used a plus 10% trim to get to 1412. So we're right in that ballpark of 3.5 tons of cooling. So just refer to your manufacturer's instructions on how to do that, or it might be on the blower door as well. So really that's it. You know, once we verified all these things, we can move on to checking refrigerant. You know, is the indoor coil clean? Is the outdoor coil clean? Good clean filter, clean blower wheel, fan blades are all good, motors are good, capacitors are good, we're set correctly, no static pressure issues. So all these things we can do, make sure we have good airflow, and then, you know, charging the system will be way more accurate, will be correct. So airflow, 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 it's really important. So just wanted to touch base on that today, and hopefully you're able to take something out of it. So thanks for checking it out. All right, have a good day.